quickly on how to read and use the igneous rock identification chart for the lab. So over here you see the word texture. So these are the textures that are listed. So plutonic is another word for intrusive igneous rocks, so the rocks that form underground. Volcanic is another word for extrusive, or rocks that form at the surface. Porphyritic can be volcanic or plutonic or intrusive or extrusive, it just depends. And then down here you have another volcanic with pyroclastic. Pyroclastic's a little different than the rest of these. They form differently than the rest of the textures. So basically, if you don't remember what these textures are, you need to go back and watch the texture video under Igneous Rock Textures under the lectures, because it goes through all these textures, and you'll be using the terms, not necessarily coarse grain, but you'll be using phaneritic, porphyritic, aphanitic. Vesicular is fine. You don't need to worry about this one down here. Glassy, pyroclastic, and pegmatitic. Those are the textures you're going to be using. Then over here you have composition, which is felsic, intermediate, mafic, and ultramafic. So felsic, which gives you about 15% or less dark minerals. Intermediate's 15 to 40% dark minerals. Mafic's about 40 to 90% dark minerals, and ultramafic is greater than dark minerals. Remember, if you need help with composition, go back and watch the video. But dark minerals do include dark reds and greens, where felsic, so if you have a felsic composition, it's generally going to be whites, pinks, tans with a little bit of black, or pinkish gray. Intermediate is going to be half black, half white. You will not see any pink or gray. And then, you won't see any pink, you'll see gray. So then if it's aphanetic or fine grain, it's going to be gray in color. Mafic is going to be mostly black, might have a little bit of white in it, but it could be green, black, and a little bit of white. And then ultramafic is pretty much things made out of like olivine, has a large component of olivine, and peridotite, which are dark greens, can be a little bit on the light green side, and so these are very, very rare. Then down here, one thing I do want to point out, volcanic glass. Obsidian is felsic. Obsidian is 100% quartz, therefore it's under the felsic composition. That's what this little thing means. So, which really the only volcanic glass you're going to see is obsidian. So if the picture is volcanic glass, just use the word obsidian. Pyroclastic, once again, go back and watch the textures. Also the volcanic lecture will help you with this. The intermediate and felsic magmas can form pyroclastic deposits, and they're made up of basically grains of igneous rocks, chunks, ash, bombs, things like that. And then pyroclastic is based off of size. So if your size is greater than 64 millimeters, it'll be here. If it's between 2 and 64 millimeters, it'll be here. If it's less than 2 millimeters, it'd be here, and it'd just be called a tuff. You don't need to write ash tuff. And then the chart gives you some comments and interpretations about the rocks. Porphyritic, once again, go back and watch text video if you don't remember how porphyritic rocks form. But your names are based off of the size of the phenocrysts and the ground mass. So phenocrysts are the large crystals, which it tells you right here. Phenocrysts are the large crystals. The matrix or ground mass are the small crystals. So if your ground mass is aphanitic, it would be on this bottom side, depending on the composition. If your ground mass is phaneritic, it's going to be on this side. So you can have large crystals with smaller large crystals involved. So that's when you would get the ones up top. So that's how you differentiate between the two. So let's say you have a phaneritic intermediate rock. You're going to go down to phaneritic, go over to intermediate. The rock is called diorite, and that's how you use this chart.